everybody. This is the section 3 notes on counting atoms over chapter 3. And what we're going to start with is some information on how we can actually determine information from the periodic table. So the first thing we're going to talk about is the atomic number. Now, different atoms are going to have different numbers of protons, and you'll recall from our previous lecture that we said that the whole number of protons in a neutral atom is also going to be equal to the whole number of electrons if the atom is neutral. Anything that is not neutral are going to be referred to as ions, and we'll kind of talk a little bit further about those in a future chapter. But for now, what we want to know is which number on our periodic table actually represents the number of protons. So we'll be looking at that here in a second. A lot of times the atomic number of an atom is going to be represented with a with that like variable z. So just kind of something to know. Sorry, I'm going to change my color to black. All right. And so what that means is that atomic number is going to be equal to the exact same number of protons that thing has. So in order to see this on the periodic table, this is going to be what we would call the periodic table symbol. The symbol is going to be the letter. On the periodic table, it's 1 or 2 letter designations. The first letter is always capital. Yeah. For this one in particular, sometimes you'll get the name, but this is kind of extra. Every time you look at a periodic table symbol, you will always get the symbol. You won't always get the name. You'll get the atomic mass. So this is our symbol. This is our atomic number. They're always whole numbers. And they're always going to be the number of protons. This down here is something we will learn a little bit later in this semester, and this is called an electron configuration. Not all periodic tables have them, but if you see something like this, that's what it is. What this tells us is that there are 8 protons in our nucleus. It also, since it's on the periodic table, means it's neutral, has 8 electrons. So protons and neutrons will equal each other when the thing is electrically neutral. In this particular case, we're assuming that this thing has 8 neutrons, but we'll talk about how to actually determine this here in a minute as well. So the number of neutrons in a neutral atom will be determined to be an isotope of that specific element. So a single isotope will contain the number of protons that will identify the element. It will also then contain the same number of electrons. Because again, electrically neutral. And then the number of neutrons is what determines the total mass of the element. Now, there are several isotopes for each element on the periodic table, and the weight on the periodic table that we see, the one that has decimals, like the one we saw for oxygen on the previous slide, this guy down here, this 15.994 is actually a measured, it's a measured like average weight of all of the different types of isotopes that naturally occur for this specific element. So our masses are going to be very, very detailed numbers that are typically decimals, but a single isotope has a whole number mass. And so we'll talk about how to actually determine how those are going to be written by using a mass number. So if we're talking about the isotope of an element, it will have a whole number mass referred to as the mass number. If we're talking about the weighted mass of an element, this is typically referred to as an atomic weight or mass, same idea. And this one is decimal based. So for instance, the isotope of oxygen that we were just looking at had a mass of 16, and the atomic weight had a mass of 15.9999. Okay, and we'll look closer at units here in a second, but for now, that's all we really need to know. So this particular oxygen atom is actually going to be oxygen 16, typically referenced as O16, or you can have the whole thing written out. You can also see this really odd looking symbol, and we'll talk about that in a second, which indicates protons as the bottom number and the mass number as the top number. Remember, that's protons plus neutrons. Okay. So there's a couple of different ways you may see isotopes written out. Now, when we write out isotopes, we do not report this number. That's not one that we would report if we're talking about isotopes. Designating those isotopes, like we said, there's two very common notations. One is to write out the name of the element plus the isotopic mass. You'll see a whole number always. So if you're given a whole number, you know it's got to be an isotope. Or you'll see this nuclear symbol, which again puts the number of protons plus neutrons on the top and puts just the number of protons on the bottom. That number of protons on the bottom, remember that this is the atomic number. And remember that this is also the identity of the element. So if you did not know the symbol, you could look at the periodic table, look for number 92, and then you would know what the identity of the specific element would be. So just please remember, this stuff will be one way of calculating the number of neutrons in a specific atom is to use that isotopic mass that you were given. So in our uranium-235 example, remember that there are 235 over 92 as far as the number of protons are concerned. 92 is the number of protons that you know because this is, again, an identifier. 235 is the isotopic mass you were given. In order to calculate the number of neutrons, we can take the mass number we were given minus the number of protons, and the only thing left over would have to be our neutrons. Another special name for an isotope is a nuclide. So this is like something that is a specific isotope of a certain element. So for instance, uranium-235 is a nuclide of uranium. So it means it's common and it is specific to uranium. Okay. If you look at our periodic table, the one on my board looks more like this guy, and this is the one you get on your quizzes moving forward. So just kind of recognize that when we look closer, not all periodic tables do have the key that you see here, but it's really nice if they do because then it kind of identifies what everything is. For this particular one, we're given quite a few pieces of information. The first is going to be the symbol. Make that arrow a little bit longer. Okay. The second is going to be the atomic number. And then this guy down here, this guy down here is, of course, the atomic mass, not the isotopic mass. Okay, don't get those two things confused. The other thing you'll get on my periodic table is the name of the element. I do not want you memorizing elements in my classroom. It is not helpful for you to do that. So what I have you do instead is make sure you understand how to read this periodic table. Okay. And if you don't have the name of the element, then you always have it on the periodic table. All right. So here's our first problem. And what we want to do is we want to figure out how many protons, electrons, and neutrons there are in an atom of chlorine. 37. So what that tells me is a couple of things. One is the name of the atom, which is Cl. If you look at the periodic table, which you can't see on my particular diagram, but if you look at a periodic table, you will see that there are a few pieces of information about this particular thing, including the atomic number. So we need the atomic number. And it looks like the chlorine atom has an atomic number of 17. So I want to figure out how many protons, electrons, and neutrons there are in an atom of chlorine-37. I know that the mass number given is 37, and that also equals the number of protons plus the number of neutrons. My number of protons is going to be the same as the atomic number. So in order to figure out the number of neutrons, I'm going to take 37 minus the number of protons, and I'm going to be left over with 20 neutrons. So far I know protons are 17, neutrons are 20. Remember that in a neutral atom, the number of protons equals the number of electrons, so my number of electrons is also going to be 17. Okay, let's see if we got it right. Our solution is going to be to take the number of protons and get the number of electrons that are equal. Then we also want to be able to find the number of neutrons by subtracting from the mass number. And it looks like we got it right. So we got 37 minus 17 is 20. And then we also got that the electrons equals the protons. So that is our solution. Nice job. Okay, I think I'm going to film this in 2 parts just because it's getting kind of long, right? So that's the end of our first part.